Hello and welcome. So, let's talk about a weird paradox in cybersecurity. How can encryption, the one thing we all rely on to keep our data safe, actually end up being our weakest link? You know that feeling? You're using encryption, you've checked the box, but you're still kind of worried about data breaches. Well, you're right to be. It turns out just using encryption isn't the magic fix we all wish it was. Let's dig into why. And that brings us to our topic today, cryptographic failures. This is the official term for when encryption goes wrong. We're talking about using weak algorithms, misplacing keys, or just messing up the implementation in a way that leaves your most sensitive data completely exposed, even though you thought it was encrypted. And this isn't some niche issue. It's a huge deal. In fact, the OWASP Top 10 for 2025 ranks it as the number 4 most critical security risk out there. What's really interesting is that this category used to be called sensitive data exposure, but they changed it to focus specifically on how encryption itself fails. That tells you everything you need to know about how important getting this right is. I love this analogy because it just hits the nail on the head. Think about it. Having encryption is like having a bank vault to protect your valuables. But a cryptographic failure? That's like building that vault out of cardboard. It looks secure, but it's really just an illusion. All right, so let's get into the nitty-gritty. How does this stuff actually fail in the wild? Well, a lot of the time, it starts with using algorithms that are just ancient and broken. Look at this table. MD5, broken since 2004 because of something called collision attacks. That basically means a hacker can create a bad file that looks identical to a good one, cryptographically speaking. And DES? Its key is so tiny that it was being cracked back in the 90s. Using any of these today is just asking for trouble. But it's not always about the algorithm. Sometimes it's just really bad key management. I mean, we're talking about leaving the literal keys to the kingdom lying around. Think about it, hard-coding API keys right into your source code, accidentally pushing them to a public GitHub repo for the whole world to see, or just never bothering to change the locks by rotating your keys. It's shockingly common. And then there's this classic mistake, weak password hashing. On the left, you've got the old way, using something fast like MD5 with no salt. That's a unique bit of data added to each password. Attackers love this because they can use something called a rainbow table, which is basically a giant pre-made dictionary of cracked passwords to break them in no time. But on the right, you see the modern approach, using something like Argon 2, which is intentionally slow and uses a unique salt for every single user. This just completely shuts down those kinds of attacks. To really put that into perspective, look at this. A password that takes a modern graphics card seconds to crack using MD5 could take years or even longer with an algorithm like Argon 2. That's not just an improvement, it's a complete game changer. That's the difference between a minor inconvenience for an attacker and an impossible task. Okay, so let's look at how all this plays out in the real world. Here are 4 super common attack scenarios. First, the all too common GitHub leak. It goes like this. A developer, maybe in a hurry, hard codes an API key right into the source code. Then, whoops, that code gets pushed to a public GitHub repository. What happens next? Automated bots, which are constantly scanning for this exact mistake, find that key in minutes. And boom, the attacker now has the key to decrypt everything. Next up, the classic password database breach. An attacker gets in and steals the whole user database. But the real disaster is how the passwords were stored. If they used a weak, unsalted hash like MD5, the attacker doesn't even need to do any real work. They just run the stolen hashes against their rainbow tables and can instantly reveal millions of user passwords. It's less like cracking a safe and more like looking up a word in a dictionary. Then you've got the man-in-the-middle attack. Picture this. You're on public Wi-Fi. An attacker sits between you and the server you're talking to. Now, your traffic should be encrypted, so you're safe, right? Well, not if the app on your device is built to just ignore those TLS or SSL certificate warnings. If it does, the attacker can just show it a fake certificate. Your app will blindly trust it, and suddenly that secure connection is wide open for the attacker to read. And finally, we have session hijacking. This is a sneaky one. It happens when an app uses a bad way to create session IDs, the token that keeps you logged in. If the IDs are predictable, maybe they just go up by 1 each time, an attacker can just observe a few, figure out the pattern, and then literally guess a valid session ID for another user. And just like that, they've taken over someone else's account. So yeah, the tech is cool, but let's talk about what this really means for a business. The impact is devastating. You're looking at huge data breaches, stolen credentials everywhere, massive fines from regulators. But honestly, the worst part might be the complete and utter loss of trust from your users. That's something you might never get back. Okay, that's enough doom and gloom. How do we actually prevent this? Let's talk about building a proper digital fortress. The absolute foundation is solid key management. This isn't optional stuff. You need to be using a real key management system or even a hardware security module to handle your keys. You've got to automate key rotation so the locks are always changing. And the number one rule, never, and I mean never, store keys or secrets in your source code, config files, or logs. Ever. And here's another hard and fast rule. You have to protect all data when it's moving. That means enforcing modern secure protocols like TLS 1.3 for everything. Not most things, everything. There are zero exceptions to this. All right, to wrap this all up in a practical way, here's a checklist. This is something every developer can and should be using. This really covers all the big points we've talked about. Use modern approved algorithms. Implement strong password hashing like Argon2 with unique salts. Use a real key management solution, no more hard-coded secrets. Generate tokens and session IDs with a genuinely secure random number generator. And please, enforce strict certificate validation on all connections. If you build these habits into your code reviews and daily work, you'll stop the vast majority of these failures before they ever happen. So that leaves us with one last question to think about. Encryption can be your greatest asset, or it can be a ticking time bomb. It all comes down to how you use it. So you have to ask yourself, is your encryption a real asset, or is it just a liability, a cardboard vault, waiting for someone to poke a hole in it? Thanks for joining me.